In this lecture, we're going to learn about static variables. And static variables are variables that live throughout the entire lifetime of your application. In this example here, we have two kinds of static variables. The first kind is the global variable we have on top here. This is a variable living outside the main function here that we have here on the bottom, and it shows up in front of the main function, and it also is in front of any other function that we have in this file here. So if you have a variable like this that isn't living in any function, it is going to be a global variable. And this variable is basically initialized when your program is starting. It is even initialized before the main function runs. So this is a global variable. Its lifetime is going to start when the application starts, and it is going to be destroyed when the application is killed, or at the end of the main function when the return statement here is executed. This is one kind of static variable, and we call it a static variable because of its lifetime. It's going to live for the entire lifetime of your application. But this is not the only kind of static variable we can have in C++. Another kind of static variable can live inside a function. And this can be a little bit confusing. This is going to be a static variable, and it is going to come to life like the global variable here when your application is starting. But its scope is going to be limited to the function where it is declared. So for example, the add student function here, when it runs, it's going to set up and initialize the student count variable here if it's running for the first time. And for the second time, for example, the initializer here is not going to run, and the compiler is going to make sure of that. But the incrementation we do here is going to run, and if we run this function multiple times, we're going to see that the student count here is going to be incrementing. This can be useful, for example, if you want to keep track of how many times a function is called in your C++ program. Okay, this is the main idea in this lecture. We are learning about static variables. We have two kinds of static variables in C++. The first one is a global variable, which is going to be living outside any function scope. The second one is what you can set up explicitly and mark it static using the keyword here. If you do this, this is going to be living throughout the entire lifetime of the application, but its scope is going to be limited to the scope of the function where you are declaring it. And here we have a few functions we can play with to really show the behaviors of these variables. And now we're going to head over to Visual Studio Code and play with this a little more and make it super clear. But before we go there, here are a few things for you to keep in mind. Both global and static variables have static storage duration. We have learned about storage duration earlier in the course. So these variables are going to live throughout the entire lifetime of your application. We have said that. Static variables are scoped to the function in which they are declared and used. We have seen that our student count variable was scoped to the function add student, and you have to explicitly say that that variable is static by using the static keyword in front of the variable declaration. If you try to access static variables outside the function, you'll get a compiler error. Global variables are scoped to the global scope of the file where they are declared, so they're going to be available throughout the entire file, and any function in the file can have access to that variable provided the function comes after the declaration of the global variable. Now that we have this information in our mind, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is static variables. We're going to grab our template files like we always do, and we're going to put them in place. And we're going to open this little guy in Visual Studio Code. Let's do that by dragging and dropping here. This is going to open our folder. We can open our main CPP file, and we can clean it up a little bit and close the left pane here. We don't need it anymore. The first thing we're going to do is to set up a function with an explicit static variable. And the function is called add student. It is going to return int. And we should really use unsigned int because we are using this to represent some kind of size. The student count can really never be negative. So we're going to use unsigned int, and we're going to say static unsigned int here. And this is going to do. Now, the main key point here is that we are using a static variable here. We are taking this variable called student count and marking it static, as you see here. And what this is going to do is going to make this variable escape the scope of this function, and it's going to stick around across function calls. So for example, if we call this function for the first time, student count is going to be initialized to 0. And if we print it out, we're going to see that we're going to get a 0. But this is going to increment. And the next time we call this, we're going to see that student count has come to 1. And here we are returning this so that we can print that. So let's try this function and really show you the behavior of static variables. They live across function calls. The left time basically escapes the scope of the function where they are declared. Let's go down and call it a couple of times. So we're going to say stdc out student count, and we're going to say add student. Okay, if we call this function, it's going to return the current count of student. And for the first time, the variable here is going to be initialized to 0. Then we're going to increment it and return 1 for the first time here. That's what we're going to print. So it is basically going to go from 1 and keep incrementing as we call the add student function here. Let's put in stdc out, and let's copy this and do this maybe 2 or 3 times manually like this. Okay, so we expect to see a 1 on the first call here. We expect to see a 2 on the second call here, and we expect to see a 3 on the third call here. And the reason we're going to see this output is because this variable here is going to escape the scope of this function, and it is going to stick around and be used across different function calls. If we didn't have this static here, this variable would be scoped to the function call here, and we would still get 1, 1, 1 printed out as we call this function here. Let's try and build using GCC. You see the build is good, so we can bring up a terminal and try to run this and run Rooster. You see that this is what we expect. We have 1, 2, 3, but try to take out the static keyword here. Let's take it out and see its usefulness. Once we take it out and we're going to build again, now the student count variable inside this function is scoped to this function. And if we call the function for the first time, we're going to initialize this guy to 0. We're going to increment it. And when we return from this function, this guy is going to be wiped out. Next time we call the function, we're going to initialize it again, and we're going to increment, and we're going to get a 1 and return. So every time we call this function, we should get a 1 returned, and that's what we're going to see printed out on the console. We run Rooster, we see that we get a 1, and our variable is basically no longer static. The lifetime is now limited to the scope of the function here. I hope this makes sense. And this is the usefulness of static variables that are scoped inside some function. Okay, let's bring this back, and we're going to build again and see our behavior again. So clear, the build is good. We can run Rooster. Now we see that this is sticking around. You can even use this inside a loop. So let's comment this out, and we're going to use this inside a for loop and call this function maybe 10 or 20 times. Why not? We're going to go down and do that. We're going to say for size ti. We're going to initialize this to 0, and we're going to keep going as long as I is less than 20, and we're going to put in our incrementation part. Let's do that. And inside the body of the loop, we're going to print the same thing we've been printing here. And you might guess what we're going to get. Try to guess. Okay, we're going to be looping for 20 times from 0 all the way to 20. And we're going to be calling this function, and it's going to keep incrementing from 1 all the way to 20, because we're going to call this function 20 times. So we should see 1 all the way to 20 printed to the console, because this is going to loop 20 times again. So let's build again. We're going to use GCC as we always do. So we're going to clear, the build is good, and run Rooster. we're going to see that this is going to go from 1 all the way to 20. We're going to loop 20 times from 0 to 19. And again, if we take out the static keyword, the lifetime of this variable is going to be constrained to the body of this function here. This is what is going to happen. And we're just going to see one printed 20 times here. Let's do that. We're going to run the task again. And the build is good. We can clear and run rooster 20 times. So let's bring back our static here because we need it. And the other thing you should know is that even if the lifetime of this variable escapes the scope of this body of the function, the scope of this variable is inside these curly braces. And what do I mean by that? Let's say we have another function here and void do something, and it's not going to take any input. And let's try to access the student count in here. Let's say we want to decrement the student count. Let's do that and say student count. And we're going to decrement that, maybe say minus student count. You see that we get squiggly lines because the scope of this variable is in the body of this function here. If you try to use it outside the scope of this function, you're going to get a compiler error because the compiler is not going to know what you are talking about. This variable wasn't declared in this function here. This is what we mean if we say the scope of this variable is going to be constrained to the body of the function where it was declared. And it is really very important to make it very clear the difference between the scope of a variable and the lifetime of the variable. The scope of this variable is within these curly braces in the function where it was declared. But the lifetime of this variable is not tied to this body. It's going to live throughout the entire lifetime of the application. And that's why we are able to keep state across different function calls. And we see this guy incrementing every time we call this function here. Okay, so this is what I want you to see. Visual Studio Code is going to tell us what is wrong. It's going to say identifier student count is undefined in the scope of this function. And if we ignore this warning from Visual Studio Code and go on and compile, we're basically going to get the same compiler error. Student count was not declared in the scope of this function here. Okay, hopefully you understand the behavior of static variables like this. Another kind of static variable we can set up is a global variable. Let's say we have an unsigned int variable. Let's make it size t. Why not? So we're going to say dog count, for example. Let's say we want to keep track of how many dogs we have in our application. So we can set up a variable like this, and it's going to be living in the global scope. Okay, the global scope is the scope which is outside any function in your file. Let's go down and comment out this line because it is giving us squiggly lines and they are disturbing. Let's say that this is going to give us a compiler error. And I think this is descriptive enough. Now we're going to focus on this global variable here. Okay, let's go on top and talk about the dog count variable here. The first thing we would think about is its lifetime. And this variable is going to be alive from the point where we run our application and this statement is executed. And it's going to die when the application dies. So the lifetime of this variable is basically going to be the entire lifetime of your application. The scope of this variable is also going to be in this global scope here. So any function that lives after the declaration of this variable is going to have access to it. For example, from our add student variable, we can go in and say dog count plus plus or plus plus dog count. Any will do. If we do this, we're not going to get a compiler error because we have access to this variable. It lives in the global scope. And in any function, we will have access to this variable here. If we go down and do something here, we can also do the same thing. We can say plus plus dog count. And this is going to compile. Let's go through the compiler. And we're going to see that the build is good. So this is valid C++ code. We have seen two kinds of static variables in this lecture. The one is what you declare explicitly as static inside the scope of some function. And this is going to make the state of this variable stick around across different function calls. And we saw that if we do something like this, for example, with the static variable and call the addStudent function, the state is going to stick around. The first time we call it, it's going to be a 0 and we're going to increment it and it's going to be a 1. But next time we call it, we're going to get a 2 because we're going to be incrementing from 1, and we can basically go from 1 all the way to any point we want, for example, through a loop here. The other kind is the global static variable, and again, by static we mean the lifetime. The lifetime is going to be basically the entire lifetime of your application, because static variables become alive when your application is started up, and they die when the application dies. As long as the application is running, these static variables are going to stick around. And this is really all we set out to do in this lecture, showing you different behaviors you need to be aware of when working with static variables. We are going to stop here in this lecture. In the next one, we're going to learn about inline functions. Go ahead and finish up here and meet me there.